All right, look here. So this is question 2. This is kind of piggybacking off of question 1. If you haven't watched that video, then go back and watch that video real quick. But I'm gonna storm through this question really quickly, all right? So we have to remember, we're looking out in the question to see what things do we see that have to do with pressure, volume, temperature, and moles. Those are our players. Remember, our goal, or our steps to getting to our goal or answering the question are always going to be to identify what formula you're going to need. These are going to be your 5 formulas to pick from. Your second step, rewrite the formula. Your third step, write the form out. Your fourth step, plug your numbers in. And your fifth step is going to be solve. If you go about these steps in order, then it's going to be pretty easy, okay, once you get the hang of it and you get enough practice. So I always read the question, figure out who are my players between pressure, volume, temperature, and moles, and how many times do I have those players. Remember, if I have those players twice instead of once, then I'm looking at either formula 3, 4, or 5. If I only have those players once, I'm looking at either formula 1 and 2. If I only have those players once, and it's not just all pressures, then I'm talking about the ideal gas law formula, which is formula number 1. Okay, so again, if I don't have anything mentioned twice, and I have anything besides pressure, then it is the first formula I have written here, the ideal gas law. All right, let's read the question, and I went ahead and I wrote out on top of each variable what we had so we can pick the formula. So if an unknown quantity of gas has a pressure, P, of 1.2 atm at a volume, V, of 31 liters, at a temperature, T, of 87 degrees Celsius, you'll notice in the last question it was Kelvin, okay? How many, which is K, how many moles of a gas do I have? All right, so my variables, again, I have 1 pressure, 1 volume, 1 temperature, and we're talking about moles, 1 time. So then I can't use formula 3, 4, or 5. They're not relevant, okay? So it's either formula 1 or 2. The fact that I'm talking about anything besides just pressure means that it must be formula 1, the ideal gas law. Step 1, identify formula, check. Step 2, rewrite the formula. Let's rewrite that formula. P, V, equals nRT. All right, step 2, rewrite the formula. Okay, step 3, write out the form. So underneath that, here's the form for this formula, okay? Parentheses, open parentheses, equals, open parentheses, open parentheses, open parentheses. What is the purpose of that? That gives me my spots, and it makes the math much more convenient later on when I tell you what to do with the numbers, okay? All right, so now I can just go back to the question and pull those things out, and then they get plugged into the proper spot. So right now, we just wrote out the form right now, and now we're moving on to plug in. All right, so what was the pressure? The pressure in the question was 1.2 atm. What was the volume? The volume in the question was 31 liters. Okay, how many moles? Well, that's the question. So we're gonna mark it with a question mark. Again, if you were like in algebra, you would put like an X or something. What's the missing variable? R. Remember, R is a constant. It doesn't matter what the question is. It is constantly repeating itself. It will always be the same number. Remember, R will always be 0.0821. Okay? That's the ideal gas constant. It is always the same in the ideal gas formula. 0.821. Okay? And then the temperature out of the question. Look here. Notice this time there is a C. This is matching with this formula. I'm not as concerned about it with the other ones. With the other ones, I don't want you to do what I'm about to do, okay? Except in certain situations. Most of the times, if you're using formula 3, 4, or 5, you will not do what I'm about to ask you to do, okay? So when you're using the ideal gas law formula, PV equals nRT, again, the temperature cannot say Celsius, but that's not a big deal. If it does say Celsius, then you just add 273, and that makes it Kelvin, which is the type that we can use. So I'm going to take this 87, and I'm going to say 87 plus 273, okay? And whatever that gives me, that's going to be my K, my Kelvin, and I can then plug that in. All right, I'm gonna do this math on the spot with you guys. No, I'm not. I'm gonna pause the camera because I can't think like that. All right, 360. So then the temperature that I can use is 360K, okay? 360. All right, now I can use that. Everything else works the exact same as though the temperature were already in the right units. What do I mean by that? This is a sentence, right? It tells me that the question mark, I'm looking for the moles times 0.0821 times 360 equals these two numbers multiplied. I don't want to know what the moles equals when they're being multiplied, so I'm going to divide them away on the other side. So I come over here, write my division sign, and then I copy those two numbers exactly in the form that they're there. So 0.0821 times the 360. Okay? Now we can say they're no longer here, and whatever I get when I put that in the calculator is going to be my answer. Now, what is another way to write this? Okay, what does this mean if I wanted to just write that in the simplest way possible? This means 1.2 times 31, okay? I'm going to use parentheses. 1.2 times 31. Then the division symbol reminds you to divide. Divided by, okay, the bottom, 0.0821 times 360. Okay? All right. Whatever that equals, when you put that in the calculator, that is your answer. All right, so this is question number 2, which is essentially identical to question number 1. Only difference is here I gave it to you in Celsius. When you use PV equals nRT, you may not use Celsius. If you get that, and then it's in Kelvin, you plug that in, and then you solve it like normal.